For this first part of the video troubleshooting lesson, I want to talk about some things that you can check within the video subsystem and what those things might fix for you. And we'll start with connections. Just like we always do, always check the connections. If nothing is showing up on the display, first make sure that the monitor is plugged into the video card and to the correct video port, and then verify that the monitor is connected to the AC outlet and make sure it's powered on. If the image on the display is scrambled, check that it is connected to the correct port on the video card also. If necessary, try removing the video card and reseating it carefully if need be. Then there's power cycling the video devices. A proper power cycle means you're turning them off and disconnecting the power, and then waiting a couple minutes, then plugging them back in and turning them back on. So power cycle the computer, the display, and any power protection equipment also. Power cycling the equipment can fix all kinds of problems, and it's an easy solution to implement. Problems such as video memory, also known as image retention, and also stuck pixels might be easily repaired by a power cycle of the display and the computer and any surge suppressor that the equipment is plugged into. You might also need to leave the display off for a couple of hours to fix a video memory problem. Now, video memory and image retention are sometimes also referred to as burn-in, but that's actually a symptom of a problem that occurs in the older CRT monitors, the cathode ray tube monitors. And CRT isn't on the objectives for the 901 exam. It's the LCDs that you're interested in for the exam, and it's really known as video memory or image retention. So try power cycling the equipment for that. Next is checking the onboard video. Check for an onboard video setting in the UFI or the BIOS. If you install a new video card to a computer that previously used onboard video, always check that the onboard video setting is disabled in that BIOS. It could conflict with the new video card. And also be sure to plug the monitor into the new video card, not the old onboard connection. You know, in this scenario, you might have two DVI connections, one that's on the motherboard integrated and one that's on the new video card. So you have to make sure you're connecting to the right one. Next is checking the resolution setting. If the resolution was set too high or was set to a resolution not supported by the monitor, you might get a distorted image or no image at all. So what you could do is you can boot into low resolution VGA mode or safe mode, and these are found in the advanced boot options menu in Windows 7 and Vista, and that's known as startup settings in Windows 8. And what this does is it starts the computer with a resolution of 640 by 480, a basic VGA driver that'll run no matter what. Then what you do is you modify the resolution setting in the screen resolution window. So bring that up now. And here's my screen resolution window. I'm running two monitors on this. This guy is running at 1900 by 1200. Well, let's say the monitor couldn't handle that. Let's say that it could only handle maybe 1680 by 1050. Well, you could boot into that safe mode, which starts with a basic VGA driver at 640 by 480, and just reduce the slider here to what you need. And the same for any other monitors that you have on the system. So that's a way of getting around that. Lower resolutions will result in oversized icons. Sometimes you'll see people with the resolution set real low, and you can see that makes the screen appear smaller here. That's going to make the icons and the images look really big, oversized. And it'll make it difficult for the typical user to view all the information required on one screen. For example, if you're using a big database or a big spreadsheet program, or if you're doing audio video editing. So simply increase the resolution setting to fix that problem, and that'll give you more screen area effectively and make all of your image and icons appear smaller. Next is to check the driver. Maybe the driver failed, or perhaps the wrong driver was installed during installation, or maybe an update to the driver is necessary. If there's nothing on the display, or if the image is distorted, or if the monitor only displays a lower resolution, you can once again boot into low-res mode or safe mode and update the driver from within the device manager, or you could do it from a variety of other places. For example, if you're, we were just in the screen resolution area, we could go to advanced settings, and you see the adapter for the video card here. This is a GeForce GT 630. Then we could go to properties and then go to the driver tab for that and update the driver from there, or roll it back if necessary if the new update causes you problems. So there's a lot of places to go there. And driver failures could also be the cause of a blue screen of death. So, your video driver could be the cause of that. So remember that you can boot into safe mode to modify those drivers. Next, check the DirectX version. DirectX is a Windows technology that includes video, animation, and sound components. It helps a computer get more performance out of multimedia and games and movies. The DirectX diagnostic tool, or DXDiag, helps you to troubleshoot any DirectX related issues. And it'll tell you what version you're running, and you can update it also. The tool gives you information about whether it's operating correctly, and that can be started by opening the run prompt and typing DXDiag, and you'll get a window that looks like this, your DirectX diagnostic tool. And this one here is running DirectX 11. Windows 7 and 8 use 11, but you can always upgrade to newer versions as they're released, as long as the update for the operating system is included, is running, I should say. So on the main screen, you have your system, and it tells you a whole good deal of information here, and tells you the DirectX version. And then you can find out more information about each display and whether there are any DirectX problems. And you might have a problem with direct 3D acceleration, and then you're going to have problems working with a lot of applications and games. Direct draw acceleration, I actually disable that on this system because I don't need it. But if you're playing games or doing AutoCAD or something like that, then you might see some issues down here. First of all, if it's disabled, it's not going to work very well, those programs. And you might see some issues down here as well that you can troubleshoot further with the event viewer and, by upgrading DirectX and upgrading the driver for the display and for the video card. And I have two displays, so it's showing both here. It also gives you some information about your audio and your input devices. So pretty cool tool to use. That's DirectX. And again, you can go to run prompt and type DXDiag to get in there. That's DXDiag. Next, check the temperature of the card. Check the temperature threshold. High-end video cards are intensely used by gamers and designers. If the temperature surpasses the safeguards in place, it might cause the card to throttle back the GPU speed, or the video card might stop working altogether. And that could cause the current application to crash, or to close, or the display could go blank. So if this happens more than once or twice, consider additional cooling fans in the case, or a liquid cooling system, or possibly a better video card if it's just being used too much. Use software to check and repair stuck or dead pixels. When a single pixel fails, it could be very irritating. But there are third-party software programs out there that could be used to identify stuck pixels and possible dead pixels in an attempt to fix them. If you go on Google or Yahoo and do a search for LCD repair or dead pixel repair or a similar term, you'll find some third-party programs out there. But always try power cycling the device first. If you can't repair the stuck or dead pixel with power cycling or with third-party software, then you might have to bring the display back in for repair or replacement. Next, calibrate the monitor. If you see any artifacts or image distortions, or you notice incorrect color patterns, or the display just doesn't seem to look quite as good as it used to, try calibrating the monitor by either resetting it from the on-screen display, or by adjusting the contrast, the brightness, and the color level. Also, you can try adjusting the color depth in Windows and check that screen resolution again. We talked about the screen resolution. And if we go to the advanced settings and go to the monitor tab, you have that color depth. Maybe it's running at 16-bit and your applications really need 32-bit to really look sharp. This is going to be especially important if you're a graphics designer, or if you're dealing with photo editing software or other video editing. You're going to want to set this to 32-bit. So check those things. Try to limit reflections on the screen. Make sure you're using an LCD that has a decent screen. Dim images could also be caused by misconfiguring the brightness and the contrast. Always remember to configure the brightness first. And once you've gotten to that optimal brightness level, then configure the contrast. Next, use a filter on the monitor. Sometimes a user will complain of eye strain. This might not be a video issue at all. It could be due to glare from fluorescent lights or from the sun coming through the window or whatever. Consider using an anti-glare filter. And we showed some of these previously. Companies like 3M make these for specific individual models of monitors. And they help to reduce that glare from all the lights and sunlight and so on. In a more secure environment, consider also using privacy filters. These will reduce the viewing angle of the screen, and only the person sitting directly in front of the screen will be able to read it. And privacy filters often reduce glare as well. Next is check for newly installed applications. New applications could cause the display to malfunction or stop working altogether. So you want to check the application manufacturer's website for any known hardware compatibility issues. And if you're working with powerful programs like AutoCAD or Adobe Premiere Pro or a lot of the games that are out there, they will often have a list of recommended video cards. And so you want to go with that list when you first build the system. If you're troubleshooting a system that already has a card and you have an issue to deal with, then you may need to upgrade the application, or you may need to upgrade the video card driver, or both, or in the worst case scenario, get a new video card in there. And if you do, again, check those requirements for the software and the recommendations for the video cards to choose. And finally, check inside the computer. I usually leave this for last because it's time consuming to open the system, unless I have a sneaky suspicion that one of the connections inside the computer is loose. So check whether the card is seated properly, and in areas where temperature and humidity changes quickly, you got to watch for the card being unseated, and that could be due to thermal expansion and contraction. And some refer to this as chip creep or card creep. Also, if the computer was moved recently, the card might have gotten jostled and come out of the slot slightly. Also, verify that the power connections and other cables are not loose. You want to make sure that those internal 6-pin and 8-pin PCI Express connections are secure. And check all the other connections inside the PC also, just to make sure. For example, if the system makes use of an onboard video controller and you start seeing garbled images or strange colors or cursor trails, then you might have a defective RAM module. Or maybe another issue. It could be anything hardware. So remember that the onboard video controllers rely on the sticks of RAM in the motherboard, as opposed to the individual video cards that have their own RAM and their own GPU. So watch for that as well. Always check inside the computer. That's about it for the part 1 of the video troubleshooting. There's a lot of things that you could check and some of the possible things that those might fix. So watch for these. And in the second section, in part 2, we're going to talk about some common symptoms that you might see and kind of do it in reverse and talk about what you can do to fix those problems.